Every time you're on a call, there's a story behind that call. And when you start breaking down that, you start to get to understand the equipment a bit more. And when you understand equipment a bit more, it makes your job easier. Because I know when I was in the field, I wasn't that confident all the time. I would walk into a room, a rack or parallel rack system. There is thousands of valves, there's dozens of compressors, there's pipes going everywhere. I wasn't very confident. It took many, many years. I'm not scared to admit it, like 7, 8 years before I started feeling confident going on call. Our industry, you need to be working as a team. When you work in a team environment, you get more stuff done, you feel more confident, and when you go to a call, you can complete that job a bit quicker. Maybe you're a phone call away to your tech, to that journeyman, to that buddy, and maybe you just need to shoot, just ask them some questions. I've seen this a lot. I've seen doing support, many technicians where they call me up and they tell me the answer, and I'm like, oh, that's the answer. They just needed to say it out loud. So maybe you have to do that sometimes. Welcome to this amazing event. This is the HVACR Training Symposium. The first thing I want to do is thank the host, Brian, the team here at Kalos. Anybody that you see that has an event shirt on, you got to say thank you. They're doing a great job here, and I really appreciate all the things they've done for these events. This is the third time here I'm speaking. First 2 times I worked at a company called Copeland, so a lot of you know that, and now I'm with a company called Refrigeration Mentor, my own company, to help educate and train technicians in the field. And my talk today is going to be on compressors. It's called a compressor story. And because I really believe that every system has a story, and as a technician, we need to understand that story. And when you start understanding the story of the system, you can troubleshoot it quicker, you can troubleshoot it faster, and be more effective and confident at your job. A few of the things that we're going to go through. We're going to break down stories. The stories that you do day in, day out when you're in the field. Because every time you're on a call, there's a story behind that call. And we want when you start breaking down that, you start to get to understand the equipment a bit more. And when you understand equipment a bit more, it makes your job easier. Because I know when I was in the field, I wasn't that confident all the time. I would walk into a room, a rack or parallel rack system. There is thousands of valves, there's dozens of compressors, there's pipes going everywhere. I wasn't very confident. It took many, many years. I'm not scared to admit it, like 7, 8 years before I started feeling confident going on call. And even at the 10-year mark, I still had some jitters depending on if I'd never been on that type of system when I was told about it. So we're going to talk about the story. We're going to get into how to prevent that story from happening again. How to prevent these compressors from failing a second or a third time. I'm very passionate about refrigeration, and I really enjoy talking to other technicians about this. So let's try to make this an interactive session. We're going to do a teardown. We don't have much space here, so what we'll do, we'll do our best. I'll grab a couple volunteers. We'll put it out here. We got some bolts loosened already, but I want to talk through the process. And I want to ask the questions, and what would you do if this compressor wasn't working? And let's work through it together as a team, because our industry, you need to be working as a team. When you work in a team environment, you get more stuff done, you feel more confident, and when you go to a call, you can complete that job a bit quicker. Maybe you're a phone call away to your tech, to that journeyman, to that buddy, and maybe you just need to shoot, just ask them some questions. I've seen this a lot. I've seen doing support, many technicians where they call me up, and they tell me the answer, and I'm like, oh, that's the answer. They just needed to say it out loud. So maybe you have to do that sometimes. So we'll do the teardown, we'll talk about it. We're going to do a picture rapid fire. So I'm going to put up some pictures and I'm going to ask you what caused that failure? What caused that story? What caused that issue? And then we're going to get into some resources that I use that you should be using. If you're not using, invest in yourself and do a little bit more learning. I'm not standing here today because I didn't do any learning. I spent years in forcing myself. Sometimes I didn't want to learn some of the stuff, and it was hard. And I didn't want to do it, but I did it because I knew I wanted to help others. I want to train and educate others, and hopefully I can teach you at least one thing today. My goal here today is you take one thing away. Even if it's just, oh, that guy's good looking. If you take that away, that could be it, right? Okay, and then continuing the learning journey we'll talk about at the end. Okay, types of mechanical issues. We're going to get into mechanical issues because this is one of the things when compressors have issues, and you have a failed compressor. I was there, I was in the field, and I've done it for many years. I'd go up to the compressor, it's electrically failed. It's burned out. That compressor is not working anymore. So you take it out, you bring it back to the supply house, the wholesaler, and you say, I got a burnout, I got electrical failure, I need a new compressor. But what caused that failure? And this is what you need to do. What is the story behind that electrical issue? Because the electrical issue or electrical failure is second or third cause of failure. Not the first cause. There is, when we talk about turn to turn short, phase to phase short, grounded compressor, there's a lot of electrical types of failures. But usually it's a system-related issue. So what is that story? Because 80% of the time we think it's an electrical failure, but 80% of the time it's that mechanical failure that caused the electrical failure. And this is what you need to understand. What is the story behind that compressor? So what is this? It might be hard to see. What's wrong with this picture? What issues do you see with this compressor? This is a scroll compressor. Does anybody tell? Go ahead. Okay, well, no, that's actually, okay, I heard it over here. That's copper plating. Okay, what causes copper plating? Acid, heat can, but acid. How does acid? So now we're getting into the story. We got copper plating, it's caused by acid. How do you get acid in a system? Moisture. How does the moisture get in a system? Bad vacuum, bad evacuation. That's the high level of it. You could have a broken brazed plate heat exchanger or something in there on a chiller, but it is really that installation, right? So now we're starting to get to the story. Copper plating is something that I didn't really know about until I worked at Copeland, and I work with the experts, and I still have good connections with them there. They send me pictures all the time and say, Trevor, you need to get this information out to the technicians because it's just costing them time and money and stress. But this is copper plating, so we figured out a bit of a story. But do you think this technician knew there was copper plating in that compressor? There's no sight glass on this compressor. So this compressor was an electrically failed compressor. So here's the story that you need to understand. So now, if they didn't look inside this compressor, they didn't know there was acid in the system, what do they need to do now on a system like that if they didn't look into it, or say they did look into it? How do I fix that system now? What do I need to do? Flush it, okay, flush. What else do you need to do? The acid dryer if you need to. What else do you need to do? Do an acid test maybe afterwards, depending on the size of the system. Now, if you're on a little tiny system that's this big and the acid test costs more than the system, then it's a different story. But when you talk on larger residential units, commercial systems, this is part of your job. And as a technician, you need to think about these things that I didn't think about in the field. You need to write down, we do need to do a follow-up call on here. Because if I don't check if there's acid in there after a few days, a few weeks, a few months, how long is that other one going to last? And then you got to go back and replace it anyway. And this is why you need to educate your customers. There's some customers that you're not going to get through to them, but you as a technician need to protect yourself and be very straight with the customer. This is what you do need because they don't know. They don't know. They just see the price a lot of the time. So this story here is that now if the technician would have opened that up, looked inside and said, okay, I know I need to do a flush in that system because maybe it didn't really smell. We know that there's copper plating that was due to acid due to improper installation. So there's a bit of a story there, right? And this here, once again, is an electrical failure, right? So now if you don't have a sight glass and you don't investigate, are you going to do this every time? Are you going to cut open a scroll every time? No, definitely not. But when you do not know why that compressor failed, you may have to. And are you going to do it on the job site? No. But you bring it back and you learn afterwards. You cut it open maybe on your own time if you have to. Because that's going to help you and bring value to your customer, to your boss. I hear this all the time and I do a lot of training with technicians. Well, I want to get a raise. I want to get a raise. Well, why do you get a raise over the next guy? What are you doing more and above your role? Are you doing things like this, writing out great detailed reports? Here's the follow-up. Here's the extra work that you could do and have when it's slow. It's very important to understand that. So this electrical failure was really caused by a mechanical failure. What was really caused by the installation of that first install. Okay? Next one. I know it's real hard to see. What is this? What's this? Liquid sludge black oil. So it's a valve plate. What's a valve? Is a valve plate supposed to look like that? No. So what do you think all that darkness is from? Excessive heat. Okay? This is important to know. Now, what's the story? What's the story besides about this excessive heat in this compressor? If I didn't pull off the head, you still may be visual, because if you look, your greatest tools as a technician is looking, feeling, touching, listening. My buddies that have been in the field for 20, 25 years, they can go and walk into a chiller plant, walk into an industrial plant, walk into a supermarket, and they can listen, and they'd be like, I know that compressor, there's something going on with that. I can hear it. It doesn't sound right. Leaking? Well, it could be leaking. So what causes overheat? What's the story behind this? Because when you go to a compressor manufacturer, all the big ones, Copeland, Bitzer, Danfoss, all of them, Carlisle, you talk about all these compressor manufacturers, they have specialists that do not know the system, know the refrigerant, know the power that's using it, but they know the story behind that compressor. And this is what we need to know as technicians. You know, and I've seen it firsthand. I inspected hundreds and hundreds of compressors when I worked at Copeland. And I work with these gurus, and they're like, Trevor, I've been doing this for 20 years, 25 years, 30 years. And you know what? The amount of compressors being open, like a semi-hermetic like this, is less and less. And I hear it from technicians saying, well, I don't have time to do it. Isn't that what you're paid for? Well, my customer doesn't want to pay me to do it. What do you mean your customer doesn't want you to pay? Are they following you around, seeing, watching you? Maybe. But you have time to at least pull a head off properly. Once again, you guys all have to be safe. Safe out there, because if you're not safe, you get hurt, you can't work, you can't get paid, you can't take care of your family. So you need to understand that safely, pump it down, electrically isolate it, take the head off. And you see something like this, there's a story to be told. So what causes overheat now? High superheat, discharge valve, what else? Dirty coils. So there's a lot of things. So this is part of the story. So you need to understand the story and walk through it as a technician, right? And we're going to dive in. Anything that's bold, it's hard to see. I'm going to dive into 3 mechanical failures today, because I don't have time to talk about all of them. What is this? And I'm pointing at the sight glass a bit more. I know it's hard to see. Low oil. Fantastic. Low oil. On a compressor that has a sight glass, that's kind of easy to tell. What happens when there's no sight glass, right? But why is there no oil in there? What's the story behind that? Pardon? Low airflow, okay. And what would low airflow cause? Build the oil up in there. What's that? Poor refrigerant velocity. So all these different things are part of this story, right? What else causes loss of oil or low oil? Leak. Leak. So you go into there, what's part of the story? Well, I'm looking for a leak. This is part of the story that you need to figure out. You need a checklist. You need to take a systematic approach when you're troubleshooting systems. You can't be going in and shooting by the hip every time. You need to take an approach, this step, this step, this step, this step, this step, this step. And over time, you have, at the beginning, you have this massive list. But over time, this list gets smaller because you know what to do. You can think about it. When I get into a site, this is what I need to look for, and this is why I need to look for it. And it tells you the story, because we're detectives, and we need to build a case to figure out that problem. And so loss of oil is a big one. That was one of the things that was the hardest thing for me to understand. Where's the oil? It's not in the compressor. Where's it at? What else could cause loss of oil? Flooded starts, washout, what else? Viscosity. Yeah, so below 0, POE oil is like molasses. So think of it, it gets super thick, and it doesn't want to move. So now, if all of a sudden you have an issue with your defrost, maybe defrost termination, something with your defrost, and you haven't gone into defrost for a couple weeks, maybe all that oil stuck in there, or freeze up. It all depends, right? But you need to understand the story. Pipe sizing is a huge one that technicians do not understand. It took me many years, and only because I did go and work at Emerson and Copeland and did field support, manufacturers and stuff to really understand it. But the value of understanding how the system's piped. As a technician, you want to be the best technician out there, you understand how to size a system, how to install a system, how to commission a system, how to start a system up, how to maintenance a system. And it's not easy. You're not going to learn this overnight, because I tried to do it, and I'm doing it for 17, 18 years now, and I feel like I'm at day 1. Okay? But take the time to understand all those different things. And pipe sizing is a huge one. If you have a 12 psi pressure drop in your suction line, there's something wrong. Is there a restriction? Is there the velocity issue? You need to understand this stuff. What else is wrong with this picture besides no oil in there? A 2 crankcase heater. So now, if we think about this, well, why did I put another crankcase? Why do you think this person put a crankcase heater there? Probably because they're having oil return issues. Now, what would happen now if that heater, for some reason, the auxiliary that pulls that in and off, turns it on and off, fails? Is that going to keep that compressor cool, or is it going to heat it up? Yeah. So you look at any compressor manufacturers, they're going to tell you where they want to see that crankcase heater, and it goes in a specific spot. It goes in a specific, I didn't know. I didn't know. You need to put it over the seam, the weld seam, and it'll tell you from the base, depending on the manufacturer, tell you how high they should have it, because if you have it too high, it's going to overheat the compressor potentially. Next one. I know it's real hard to see these ones. Anybody ever open a scroll before? Show of hands. Chris has, Bill, a couple people. If you haven't opened a scroll, you need to. You need to take the time, even if it's not on a job. Okay, how about this? Where does the scroll go? It's unwarranted, no warranty on the scroll compressor. Where does it go? It goes in the scrap bin. So your job is now, I challenge all of you here, and everybody that's online watching, I challenge you, when you have a failed compressor, it's out of warranty, and it's going to go in the bin, keep it, cut it open safely, safety glasses, gloves, a good Sawzall or a zip cutter. Some people use plasma cutter. But I challenge you to look inside to figure out why that compressor failed. It's out of warranty anyway. It's going away. You need to understand this stuff, because if you don't know that story, how long until the next one fails? And it's very important as a technician to understand the story. When you understand the story of that system, you know how to troubleshoot it. Your confidence is going to go up because you're going to figure this out, the story. Okay, this one here, flooded starts. These special inspection people that work at these large manufacturers like Bitzer and Copeland and Carlisle, they look at these pictures and they can tell you what caused that failure. And they can tell what the technician thought the failure was. Okay, so like this one here, electrical failed compressor. You see this is something called scroll galling. So it's actually metal on metal. There's supposed to be a nice foam of oil in between there. But you get what's a flooded start? How does a flooded start even happen? And we're going to dive into it. How does a flooded start? What causes a flooded start? Liquid migration. Okay? Because refrigerant wants to go to the coldest part of the system. Well, why would it want to go to the compressor? Oh, it's outside and it's cold. Okay, well, so what are you going to do to prevent that then? Crankcase heater on it. Maybe a second or third one if you need to, eh, Bill? No. What else? Pump down, solenoid. We're going to talk about this a little bit more. But it's important to understand that. But if you didn't look inside this compressor and you put another one back in, I've done it tons of times. I put a new compressor in. I tried to find out that issue. What caused me to be here to fix this compressor that's electrically failed? And there was times, it must have been the relay. It was loose. The wire was loose. I did it. But you know what? I didn't know the story of that compressor because I didn't cut it open. I didn't look inside. You work on semi-hermetic compressors, you need to look inside them. What do you need? If you take a head off of a compressor, what do you need? What is the one thing you need? What is it? Safety glasses. Okay, you got the safety glasses. You bump it down properly. You got it electrically isolated. You take that head off. What do you need if you're going to look at it? You need gaskets. Okay? And if you don't have gasket there, you put the head on. You call the wholesaler up or supplier and say, "You got these gaskets? Order me some. I'm going to put it back on for now, and I'm going to have to come back and do a follow-up." Because it's like your car engine. You're working on your car engine. You pull your head off your car engine. Are you going to leave that old gasket on your head? Yeah. So, and then here's a picture of a semi-hermetic. So if you take the pump off, we're going to talk about this in the teardown. When you take a compressor apart, semi-hermetic, you don't have to pull the whole thing apart. You don't have to do what they're doing at the manufacturer level to inspect it. You need to take a few things off. You need to pull off the head safely, take a look inside. You need to pull off the pump and look inside there. And that's really all you need to do. If you want to dive deeper and pull the stator cover off and look, you can. You can totally do that, but it's not necessary to find the different tips and tricks that we'll talk about today. Next one. What do you think caused these failures or issues? Slugging. Yes. Okay, let's start the story of a slug. How does a slug happen? How do you have a compressor slug? That's a TXV stuck only on one type of compressor, not regular, not a refrigerant cooled compressor, an air cooled compressor. Yes. Say, what was that again? Improper superheat. No, not for slugging. Good try. What causes a refrigerant cooled compressor, which are scrolls, which are semi-hermetics? Filtered right out. Well, that'll be restriction. No, close. Start, stop. Okay, start, stop. We're getting closer, but most start, stop is oil issue. What causes a slug? This is very important. As a technician, you need to understand this. Proper charging, okay. How would something break inside a compressor? What's supposed to be in a compressor? How about, let's start there. What's vapor? Okay, what would cause that? Would vapor cause that? No, so what could cause that? What are two things that could cause that? Liquid. I love that, liquid, because I used to say liquid too, and I was really corrected by manufacturers when I worked for them, because what do you mean by liquid now? Liquid refrigerant or liquid oil, right? Could be two different things. But you need to understand, so now liquid. Now I get liquid in there. How do I get liquid in a compressor? It's not boiling off, but when it doesn't boil off in the evap, what is that considered? That's flood back, right? So how do I get refrigerant in a compressor to do something like liquid refrigerant? Keep going. Keep trying. What is the one that we just talked about just before? Flooded starts. How many people know a slug is caused by a flooded start? Show of hands in a refrigerant cooled compressor. Be honest. Okay. This is important. This is key information you need to understand. That flooded start, because we talked about it, Chris said, that refrigerant migrates back to the compressor. It condenses. It stratifies in the oil. It stratifies in the oil. And that compressor starts up and then, bang. It causes things like this. Oh, it causes things like this and things like that. So now when you think about the story, okay, so the system is off, the auxiliary contactor failed, the crankcase heater was not working at that time or it failed, the refrigerant migrated back to the compressor was off for a long period of time, so it stratified in the oil, the refrigerant, and when that compressor started up, bam, you had a flooded start, a massive flooded start, which caused a slug. So now here's the story. You know, you could go and you put your gauges on this compressor now, and the compressor's still electrically running. Or it could be electrically failed. Because you put your gauges on this compressor right here, what are your gauges going to say? It could say equal, yeah. Because there's nothing running, nothing pumping, maybe a few PSI off. But you need to understand it. But if you don't look inside, how do I know it's a slug that did that? How do I know it was a flooded start that was caused by the slug? So this is what you really need to understand when you're doing any type of system. It doesn't even matter if you're working on smaller equipment. You want to understand what caused that failure, because when you understand what caused that failure, you're going to change your troubleshooting game. Okay? And I missed it a little bit on loss of oil, because I'm not going to dive into that a little bit deeper. A lot of you work with compressors with no sight glass. Is that correct? Okay. You have a compressor fail with no sight glass. What is the one thing you have to do? The compressor's failed, and you need to do this every time to make sure you understand that system, that story. What do you need to do? Pour it out and measure it compared to what that manufacturer says. Because what if you take it out and you dump it out and it says it should have 20 ounces of oil or milliliters, wherever you're listening from, and it's only had 2 ounces. What does that mean now? That's oil somewhere, okay? It could be leaked out, like you mentioned. It could have had a leak, but you walk around and there's no leak there. Now where's the oil? It could be in the evaporator. So now that compressor, how would it have failed if I had no oil in that compressor? Say the one we go back to, the one with no sight glass you're working on. And it failed. What would have happened at that failure? Because all the oil's in the evaporator, we'll say. What was that failure? Shavings. Locked rotor. Who said it? Great job. Seized compressor because you got no oil. It's just like your car engine. You drop the oil in your car engine, you go drive 100 miles. See what happens. Okay, so you're going to have a seized compressor. So that first compressor is going to fail by a seized compressor. So you take a new compressor, you put it there from your service replacement, from your wholesaler, and you stick it in and you install it. Okay, and the compressor, it starts to run. And then 2 weeks later or a week later, you get another failed compressor. Do you think it's probably a seized compressor again? Could be a seized compressor, but it could be too much oil. Right? Now you got a slug because you got too much oil. So these are the things that you need to think about when you're building your case, when you're troubleshooting. And you know, over time it'll get quicker and faster and easier, but you got to start somewhere. Building that story, building that case. Okay, here's one more. Last one. There's a little bit. There's the crank. Scored crank, yes. But why is it scored like that? Because it can score that way different ways. Spun a it's spun a bearing. How do you spin a bearing in a refrigerant-cooled semi-hermetic compressor just like this? No oil, but how come there's no oil? Washout. Okay? And what causes a washout? Liquid flood back. So here's the story. Do you see how we're coming up with pattern of how this is happening? And there's ways to test this stuff to understand what caused that compressor to fail. This one here is something called shake hands with the crankshaft, and we'll talk about that. A few simple tests, things to look for, it's going to make your job super easy. Okay, compression ratio. What is compression ratio? This is something that, you know, I did not think about. I learned about it in school, but I never used it in the field. Okay, yes. So your absolute discharge over your absolute suction. How do you get absolute now? Yeah, it's absolute pressure, 14.7. Oh yeah, no, it's atmospheric. Absolute, sorry. 14.5 would be bar. So 14.5 is bar, another unit of measurement. 14.7 is atmospheric pressure. So you, depending on where you're at, and if you're up in a higher altitude, it's going to be different. But here is 14.7. I say 15. Don't even use that number. So I use 15. So you have, for an example, you have 275 psig. You add 15. You get 290 psia. Okay? Then you get your suction 55 plus 15 psia is 270 psia, sorry, 270 psia. You divide them and you get 4.1 compression ratio. Why are you telling me this, Trevor? Why does this even matter? Well, compression ratio is very important. Because what does compression ratio do to the system, an operation envelope of a compressor? Why would I even tell you this? Everything's designed around that. Is it? Do you think high temp application? What about ultra low temp that runs into a vacuum? Your suction. You know, I'm just, you know, but different application will have different compression ratios. Compressors are designed differently. You cannot take an air conditioning compressor and go throw it in a low temperature application. Copeland does have a few that'll do a wide range, but the standard compressors, you're not just going to do that. They're designed differently. They're built differently because of different compression ratios. Okay, and why this is important, because when you have high compression ratio, what does that do to the system, to the compressor, and to the story of it? What is it? Heat. A lot of heat. A lot of work. It's doing a lot of work that does not really necessarily need to be done. So what would cause high compression ratio now? Overcharge, dirty coil. There's a list and list of these things. Low suction pressure. What's worse? High discharge or low suction now? So how about this? How about high discharge, you're going to have a higher compression ratio? Show of hands. How about you're going to have higher compression ratio with a low suction? We got 4. It is low suction. So you got to understand when you have that pressure drop in your suction line, that's way worse. And you got to understand what caused that. You got to figure out that story. So for people that do metric, 19 bar plus 1 bar. Now you see I do 1 bar, it's really 14.7, but then you do the calculation again, 20 bar over 5 bar, you get 4-to-1 compression ratio. Way easier math, eh? The thing about it, it doesn't matter what units you use. Low temp application, you're going to be like 10-to-1, we'll say. Medium temp, 5-to-1. Air conditioning, 2 to 3-to-1. Besides CO2 refrigeration, I'm not going to get into that, but subcritical applications are real low compression ratio. But if you don't understand compression ratio and you don't understand that it's building and causing a lot of heat, you're missing a part of the story. It doesn't take long to start learning this a little bit more. Here I got a picture. Always check the discharge temperature from where? How far? 6 inches. Excellent. Okay. And then you want to keep it below what when you check it? 225. Who said 250? There you go. You're not wrong, because Bitzer says 250. Copeland and Carlisle say 225. So it depends the manufacturer who you're working with. This is stuff you want to understand. I would say 225 anyway, because you're on the safe side. Because inside the head of the compressor, right at that discharge point, right where it squishes that last piece of gas, that's the hottest point. Same with the scroll. Right when the scroll or a screw compressor, doesn't matter, right at that last compression, that is the hottest point. So from 6 inches inside the compressor, it could be 50 to 75 degrees hotter. What happens to POE oil when you get it over 300, 320? Starts to lose lubrication. 350, 400 starts to break down. So you need to understand this. Okay? And this is right here. Every 1 degree increase in your suction is 1 degree in your discharge. Doesn't matter what units you're using. You need to understand that, because if your return gas temperature, your suction gas temperature, whatever you want to call it, because there's so many terms in HVAC and refrigeration, whatever you want to call it, you need to check that. What is my return gas temperature? What is my suction line temperature? What's my suction gas temperature? Because you need to understand, this is a refrigerant-cooled compressor. Why am I coming with 75 degrees back to this compressor, and I'm trying to get a 35-degree evaporator? That's you're picking up a lot of heat. Okay, I better pick it up here. I like talking. High return gas temperature, no insulation on the suction line. So you have Chris had a great video I watched one time where he's showing that the line sets running across the roof, the suction on the roof, and the insulation's failing. So as a technician, he commented on it. Look at this insulation. It's bad. You need to do this. You're a detective as a technician in the field. Maybe that customer's not going to want to change it, but you got to know, maybe I'm picking up 10 degrees more because of this line is not insulated properly. This is why the compressor's overheating a bit, and it's going to lead to a failure earlier. You need to understand that. You need to build a case on every system you're working on. You need to build that story, and when you understand the story, you're going to troubleshoot faster and quicker. Okay, operation envelopes. You really need to understand these. Okay, I got one here, courtesy of Emerson. Here's a picture of their ZF K5. This is an operation envelope. How many seen an operation envelope of a compressor before? Show of hands. Not enough of you. And that's okay. But this is where you're going to start to learn and understand, because if the system's running here, 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 or here, here, depending on the motor and the Bitzer compressor, you're going to lead to a failed compressor. And each one of those things will tell you a sign. Well, I'm running at a super high suction when I'm up here. Why am I running at such a high suction? You need to think about that as a technician. Or you're running out here. Why is my low pressure control not cutting out before the operation envelope? Because now I'm running outside the envelope, doing work on that compressor, potentially causing damage that's going to lead to an early failure. And I've seen compressors are built. These manufacturers like Copeland, Bitzer, Danfoss, Carlisle, Bach, I'll name a bunch of them. They don't build compressors to last a year or two. They last 10, 15, 20 years. That's what they're built for. But us as technicians or the customer themselves not doing maintenance is what causing the failures, earlier failures. Do things happen? Yes, there are compressors that are, at the factory that are not assembled properly that make it out to the field. by manufacturers. It does happen. But these large compressor manufacturers, they're pumping out good quality equipment. A lot of what I've seen, and I've tore down hundreds of compressors, is that it's system-related issues. And usually the story's not told. They don't know the stories. The people that are in the labs pulling them apart are telling the stories of the compressor. Additional cooling methods. So if you work in low temp application, and I'm even seeing it in, I believe, in heat pump application where you have something called liquid injection. You need to cool that compressor down because the compression ratio is so high. Remember we talked about high compression ratio, high heat? So now you need some sort of additional cooling. It could be a trev valve, it could be a DDC, it could be a captive, whatever it is. It could be a fan. But you need to understand the story of the compressor. Because if I'm running in this area with this compressor on these refrigerants, specifically those refrigerants, I need to have liquid injection. I need to, or that compressor is going to fail. So you need to understand the story. You need to understand that compressor that you're working on as well. You need to understand the manufacturer of it, because not every compressor is built the same. I used to think scroll's a scroll, it's easy, no, it's AC scroll, it's all the same. It's not. Cobalt makes over 25 different scrolls. They work differently. They're different sizes, different components, different internals. You need to understand that stuff. Does it take time? Yes. Are you going to learn it overnight? No. But have the confidence in yourself to learn that and want to learn that. Chris?
I'd say I'd point out that you need to be concerned with that if you're converting the refrigerants too, because you could be using an R22 compressor and converting it to 448A. You really, really need to focus on getting that compressor clean in that.
100%. So Chris brings up a great point. Retrofits. How many of you done refrigerant retrofits then? How about that? Anybody? Okay. You need to read some guides and learn about it. You go to a Sporland guide and they'll tell you, you need a size, that's a solenoid valve. You need a size, a TX valve, depending on what refrigerant you're replacing it with and from, R22, 404. And they're going to say you're going to have to change the valve because the gaskets are not going to work, or you've got a high percentage chance of leakage. And I've seen this time and time again. Contractors go in, I'm just going to do a retrofit. We're just going to pull out the gas, put the new gasket in. It's a drop-in replacement. We're all good. There's no such thing as drop-in replacement to me anyway. Maybe you guys might think of it. But you do have to check superheat. You do have to make sure it's the right oil. You do need to do all these checks. So for me, that's not a drop-in replacement if I have to do all these checks. Drop-in replacements, pull something out, put it in, and I'm gone. But that's what the technicians are doing, and they're leading to failures. Okay, quick question. When you have high compression ratio, this will cause the compressor to what? Do less work, flood back, overheat, run normal, or slug. Okay, we got that point across quite well. Okay, flooded starts. We talked about this. What causes flooded starts? Liquid migration. Okay, so we got vapor coming back to the compressor. It stratifies in the oil. The compressor fills up with refrigerant, and then bam! You got a good looking scroll set inside there. Scrolls are tough though. They can take a few of those, but they can't always hit them. I watched in the field many compressors by manufacturers get taken out. And when you start hearing marbles in a scroll compressor, shut it off. I'll tell you right now. The damage is really already done, to be honest with you. Maybe you don't want to shut it off. But when you hear marbles, you're in trouble. That compressor's in trouble anyway. Maybe you're not. There's also another thing that you need to look for. Maybe the refrigerant's coming from the discharge side. So you might need a check valve. And maybe the manufacturer of the equipment didn't even know that. This is why it's our job as technicians to dive in a little bit deeper, learn the story of the equipment, learn the story of that compressor or that system. Do I need a check valve? But if you didn't open up this compressor, how do you know that it was a slug or a flooded start that caused a slug that caused the failure? Because when you go there as a technician, what are you going to do? You're going to change it, but what's your first check? The compressor's not running. You're going to check if there's any gas, and then what are you going to do? So there's gas in it. You got gas in it. So you're going to take your meter out, and you're going to check it, and you're going to have a dead short, or an electrical failure, or turn to turn short, or phase to phase short, or winding short, whatever it is, or grounded compressor. But if I don't know that took a slug, how do I know how to fix the problem? You're going to put a new compressor in. You're going to watch it. You're going to turn it on, and it's going to work for 4 hours straight, and you're going to watch it, and you're going to be like, there's nothing wrong with this. And what, and then I'll sign it off. I watched it. I got the right superheat. I wait till it came down, and that was it. You walk away. But that night, while you're not there, and it goes into defrost, and all of a sudden the compressor washes out again. Or you get flood back at a certain time. Or at night, those end users, they'll open the doors, they'll turn off the fans or whatever it is. But if you don't look inside that compressor and you don't understand the story of the compressor, you're just going to be replacing another one afterwards. Okay? This is kind of what it looks like inside. You open it up and you see what I call scroll galling, or the manufacturer calls scroll galling. And this is a flooded start. This is a slug caused by a flooded start. And this is 3 causes of failure. So remember, as a technician, you'll go up and now I got electrical failure. But this electrical failure was caused by a slug. And that slug was caused by a flooded start. You getting the story now? Starting to understand that there's causes and effects. And this is there's 2 mechanical issues that led to this electrical failure. And this is, as a technician, what we need to know and need to understand to be better, to get better. So you feel confident when you say this compressor is a failed compressor, you know 100% it's a failed compressor. Because when I did work at Coben, I seen dozens and dozens and dozens of compressors come back. I put them on the bench and they run totally fine. There is nothing wrong with it. And I'm talking about $4,000, $8,000, $10,000 compressors. And I'm running them on the bench. And when I send it to the contractor, because I have some friends out there, they ask me, Trevor, can you inspect this when I work there? And that's what I do. And I send them a video of this $10,000 compressor running. They're really upset. Their pride is hurt because they're a good technician, but they made mistakes and they missed something, right? And they're like, well, I didn't check that because I didn't know or I forgot. Okay? Flooded start prevention, we talked about a cranky heater, pump down cycle, bump start cycle. Put the compressor in a warm location. Okay, once again, if you have a compressor that is flooded start, you can see it. What do you look for if your compressor is off and it has a flooded start and it has a cycle last? What are you looking for? Foam. You're going to go look in the sight glass when it starts up. You look inside there, and if there's an explosion of foam in there, that's liquid refrigerant inside there. Is there like little, is there bubbles sometimes in the oil when it starts up? Yes. But when you get a full thing of foam, you can tell that's a flooded start. And if that is happening, you got to figure out what is causing that, and you need to stop it. The damage is done. You're going to lose a bit of efficiency, I'm sure, but you can protect that compressor to last a few more years. And it's very important as a technician to protect that equipment for your customer because they don't know the difference. They're paying you good money to do a good job. And when you understand what's going on in that system, it's going to make your life a lot easier. Okay, floodback. We talked about this already. What causes floodback again? No, liquid migrations, flooded start. It's expansion valve, but what causes it? Like, what is it? What is actually, what's the story behind it? No, it's no superheat. Anytime the compressor's running and liquid makes its way back to the compressor. That's what floodback is. Anytime the compressor's running and liquid refrigerant's making its way back. Okay? And so we heard, okay, you can have an issue with your metering device. That causes floodback. What else causes floodback? Low airflow. What else causes okay, now we can break down low airflow. How does low airflow how do you have an issue with low airflow? What causes low airflow? Fan's not fun. Coil's dirty. Plug coil. Look, the couch, yes, the couch looked good in the return. So look at all these different things that we're talking about to build that story. It could be one of those things, but that's part of the story. What one was it? You need to understand this. Maybe it's a plug drain and the water filled up into the coil and it froze the coil up and then it stopped the airflow and then now you can't boil off that refrigerant, so now it starts to make its way back to the compressor, which leads to a floodback situation, which causes that compressor an issue. Does it fail right off the bat? No, unless it's really, really bad. And it's like copper plating. I talked to my friend Steve Wagner. He works at the Copeland plant, and which one is it again? The semi-hermetic plant anyway. And he said, Trevor, he sent me some pictures. He's like, look at this picture. I might have it coming up. I shouldn't talk about it. But anyway, I'm going to tell you. He's like, what's wrong with this compressor? I'm like, it's copper plating. How long do you think it's been running in the field? 2 weeks because of copper plating. Okay? Also, he sent me another picture. See, it looked exactly the same. Exactly the same. He's like, Trevor, how long did that compressor run for? I was like, 2 weeks? No, that was 2 years. So you need to understand that copper plating, for getting off topic here, could be 2 weeks, 2 months, 2 years. So do a good installation there. TX valves. Metering device, low airflow, anything that you cannot boil, and when you cannot boil off that liquid refrigerant in the evaporator, because you're supposed to absorb the heat there, and it makes its way back to the compressor, is flood back. But you need to understand that story. What caused the flood back? Where did it start? How do I fix it? How do I make this not happen again? Okay, no superheat. So if you check and it has no superheat, it's bad. If you have a regular synthetic refrigerant and you're below 10 degrees superheat, you know, at the lowest point that it could be, well, you might get away with it without causing a little bit of damage. 20 degrees, that's what Copeland's looking for. Superheat back at the compressor. 15 degrees is what Bitzer is looking for. So you need to look these different compressor manufacturers up. But now, if I talk about new refrigerants, there's a refrigerant called R513. I don't know if you ever heard of that refrigerant yet. But now the minimum is 20 degrees superheat, not 15, not 10, 20. CO2 could be 20 degrees or 36, depending if it's transcritical operation or subcritical operation. So you need to understand the equipment you're working on. And so you understand the story when you have an issue with the system. Okay? So if you see a compressor looking like this, you need to check the superheat to make sure, well, this one here I know for sure is flood back. But if you don't take your gauges out, you don't take your temperature probe out, you can't prove that it's flood back or not. Because you could be doing a low temp application, it's really cold, you're below zero, and there's lots of humidity. That's going to want to, that could be normal. Okay? And then inside a scroll, if you pull up part of a scroll apart, and how to open up a scroll. You safely pump it down, remove it. It's out of the system now at this point. You want to put it on a pallet, screw it down, put it at C-clamps, hold it down, safety glasses, gloves, a good sawzall, and right below the line here, look here, I got one done right here. So right below this well mark, you just go right around. Smaller compressor is super easy to go open. Chris has done it lots of times before. The big compressor, you're working on 40-ton compressors. It's a lot harder. It takes a lot longer. You might need a few blades. But I say start with the small ones to look inside. Find out from your supplier if it's warranty or not. You know, just double check. If it's out of warranty, it's fair game, right? So, but learn from that. Okay, flood back prevention. Checking that superheat that we talked about. Okay, if you're in a critically charged system, overcharging could be an issue. So you want to make sure that you do this. And here's a bulletin from Emerson, AE 221182. I recommend reading that book, that manual. I've read it dozens of times and I still learn stuff from it. Okay, what time are we at here? Perfect, we got 30 minutes. Woo! Okay, so I want some volunteers. Anybody want to volunteer to inspect the compressor with me? Okay, great. Anybody else? I need at least one more. Come on up. Okay. Really what I want to do, let's roll this one over here so everybody can see. Okay, let's take this off. So here's some safety glasses, some gloves for you. Oh, this one's not, they didn't take the bolts off that one. So we're going to do a different compressor. Okay. So what's your name?
Stefan.
Stefan, Trevor.
Hi, Trevor.
What's your name?
Alex.
Alex, nice to meet you, Alex. Okay, so compressor's out, or even if it's in, first thing, what do you want to do?
Check it electrically.
Yeah, so isolate the power, lock it out, right? Make sure that's done first. So you want to check it electrically. Okay, we did all the safety parts. You want to check it electrically. There's a meter right there. Do you want to check it? And if you haven't used the meter before, we'll figure it out together.
Okay. All right, we've got resistance, right? I haven't used this one.
Yeah, that's okay.
CSR.
So there's 3 leads on this one. And the first thing you want to check is make sure what type of compressor in it is it. So it's a 208, 230 volt, 3-phase compressor. Okay, step 1 is checking the resistance. Getting anything?
0.25. How do I know which one is CS9?
There's on these ones it's L1, L2, L3. It's three-phase, yeah.
Alright, we had 0.25 between L1 and L2. 0.21 between L1 and L3. And we have 0.19 between L2.
Okay. So do you see how Stefan did it? See how this is shaking right like that? This is not the way you need to be able to do this. Okay, I've done it before because now this is loose. You don't get a good connection. So the best way to do it is right from the tips. And every compressor, doesn't matter if it's a scroll, you want to go right from, these are the lugs that go right to the windings of the compressor. It's all over the place. Okay. So one thing you need to do, and it doesn't matter if it's a scroll, it doesn't matter if it's a semi-hermetic, right here is something called an insulator plate. This little insulator plate right here. And I've seen many, many compressors come back when I was inspecting them for Copeland, come back, and all it was this insulator plate. No different on scrolls. They'll have a little, like the little black insulator plate that's on the scrolls. You'll go right up to it and you'll check it, and it's a short. It's a dead short. But the problem is there's a carbon tracking on that insulator. So you need to pull that off and do it straight from the compressor. So now he's going right from the compressor. Now we got 0.4. We had 0.2 before, and then we had something all over the place. Now we got 0.4, 0.3, 0.4. Okay, so that's good. But we're not done there. Because now, as you can see, there is another terminal plate. A terminal plate right here. This could be the issue. So this is where you need to dive in a little bit deeper. Okay? So I don't think those ones aren't loose. But this is very important to do because you don't want, this is not a cheap compressor to replace. And let me see if we can. I don't know if this will do it. Yeah, there we go. Okay. And the thing is, if this is on the middle of a roof of a building, you got to get a crane. You got to get a team of guys. You got to get plywood and maybe put the plywood down and roll it across the roof. I've had to do it. But if it's only a terminal plate and it's like $50, $100, maybe $150, saving your back, saving your customer some money, saving the time because it could be 50 degrees outside and you're burning hot or 40 degrees out. So once again, you got to dive a little bit deeper, understand the story of the compressor. And you do this, you're one step ahead of the next technician out there. Because a lot of them aren't checking this, diving that little deeper. They go right from the terminals and it's a short. But dive a little bit deeper into it.
One thing I'd say to point out is obviously this one's been opened, but make sure that it's not sealed and there's not plugs and you haven't built up pressure inside of it too.
Yeah, we'll get to that. Yeah, for sure. So we're just on the electrical side here. So now this here, we can't tell if it's good or bad yet. But what do you do with a compressor? It doesn't matter if it's a Copeland or a Bitz or a Danfoss. What are you doing and where do you take that number? Does anybody know when they get the resistance what to do with it? Go to the Copeland mobile app and check it out there. Go to the Bitzer software, check it there. Go to Carlisle, Tecumseh will have them. They all have them. But if you're gathering information and not using the information, you're doing yourself a disservice. Because you need to understand that stuff. So Stefan took it off. Oh, we might need something to bang it off. Don't have a hammer here. Do you? We might not get this one off. Yeah, it's on there good. No. No. Oh, sorry. Gotta flatten it. So we can't take it off. But guys, you need to pull this off if it says something bad. And then when you do it from here, like look at this. I can push it down, right? So this is tied to the windings. So I've seen it before. Like they got the bolts off here. Let's take this off. Take this whole plate off. See if we can knock that off. I've seen it before where in behind here, the wire came off. And all you had to do was put that wire back on, get a gasket, and this compressor here could be back up and running. Instead of going through that big process, like I said, getting a crane maybe or getting 2 or 3 guys. Yes, you want to have work, you want to have job, but you want to work smart. But replacing a compressor that's not failed is not smart. Okay, I just want to open this up so some of you have not seen this before can look inside it. And we may not get it off. Max, is there a hammer back over there or anything, you know? Okay, so we'll see if he gets a hammer. So we checked it electrically. I think it may be okay. What did we get? 40.4? We got 0.4 in all of them?
No, we didn't check all of that.
So first thing, electrically. Is it failed? Does it not fail electrically? That's only step 1 of the story. Okay, if it's good, okay, it's good. If it's electrically failed, what's next? What caused that electrical failure?
It moves around a lot.
Yeah, so it's bouncing around. So that's concerning. Okay.
Big differences between all of them.
Yeah, so there's something going on with the electrics. So we know that. So the next step, when you're open up a compressor, you want to do it safely. You do not want to just pull out all these bolts and just bang the head off. Because like Chris said, this could be full of refrigerant under it. Even though you pumped it down, maybe there's a leak inside there and you didn't get it all out. So what you want to do is leave 2 bolts in there a bit. Take all the rest of them. So take all the other ones out and just leave 2 in there a little bit. And you want to knock it. Because you could get sprayed. I got sprayed before with oil blowing right in my face, refrigerant in my face. Not very fun. But you want to be safe too. You got to be wearing your safety glasses. So you leave 2 bolts in, just like that. You take a hammer and you knock it. So we're loose now. So we know there's no one. So you can pull those ones out now. First step when you're inspecting a compressor. Well, first step is to get to this point, right? But you want to, one of you take it off and flip it over and show everyone. So you want to take a look at it. So you want to look inside here to see what the gasket looks like. There's no gasket. You know, no wonder it's okay. So you want to take a look and see. So that gasket was probably ripped off. I don't know if it was leaking. It's hard to tell. It doesn't look like there's any carbon tracking because that's what you're looking for. Now, if I had a blown head gasket, I probably would see marks somewhere here, here, here. Okay, you can put that one down. But I think the gasket was just old and it ripped off and it stayed on there. So you got to observe that stuff. Now it looks black here, right? It kind of looks like overheating. But if I can rub this off, is that overheating? No, it's probably mechanical wear. So let's wipe it off.
Oh, wow, it's going away.
See how now it's all clean now? So this here is most likely mechanical wear. So this is the story you're starting to think of. Well, what can be mechanical wear? Lack of lubrication, but what causes this? Your wrist pins, your rings, your rods, whatever it is. Pieces of that compressor now are up here. So is this overheat? No, it's most likely mechanical wear. But you need to figure this out. It could be flood back, because it could be the main bearing. It could be a little bit of overheat, but you need to understand the story of these different types of mechanical issues. Okay, let's take this one off here. So now we looked at this side. So these ones, they look good. These are discharge backers. So if you flip it over. So now we got some action happening. So what's missing there? So what do you guys think these are? And some of you have never worked on these, but these are the discharge pucks, they call them, or discs. That's okay. Right, so what would have caused this?
That's got to be plugged back because it's way under there. Pushed it.
Okay. Anybody else? We talked about this. What caused this? Slug. Okay. And how do you get a slug in a refrigerant-cooled compressor? Flooded starts. Okay. Now this one's even more interesting because you can dive a little bit deeper. Because now I got this discharge busted, and this compressor will still run. If it's electrically good, and it just took a slug and you got to bust it, what's your gauges going to look like?
Less discharge pressure than usual?
So they're gonna have, is it gonna be a higher compression ratio or a lower compression ratio?
Higher compression.
Lower compression ratio. Yeah, that's
Sorry,
okay.
a little dyslexic sometimes.
No, that's okay. Lower compression rate because you're not doing as much work. I'm not doing any work in this cylinder as it compresses. Okay? But now this took a slug. This discharge is blowing. This discharge stops the discharge of gas going into the suction. Do you agree with that? So what is going on this piston now with no discharge? What's happening there? Leaking by, but is there discharge pressure pushing down on that piston or not? Yeah. Because when this pushes up, you discharge out of here, and this opens up, and then it closes. Opens up and closes, open up and closes. Now if I don't have this here to stop it, what is happening on this piston?
Hammering?
Pushing down on it. So now I got a lot of pressure. So now I got my piston trying to push up, and I got discharge gas pushing down on it. What does that lead to now? Does anybody know? Wear, what type of wear? Wrist pin wear. And this is where, like, if this compressor was electrically good, mechanically good, and a technician came in, oh, it's just a discharge. Everything inside looks good because it doesn't look too bad. And they don't check your wrist pin, you could have a knock. It'd be knock, 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 and in a few weeks your customer's going to say you got to change that compressor anyway. So how long did this, we got the system out and everything, there's pump down, but how long would this take you, this amount of time to do in the field?
10 minutes.
10 minutes, half an hour, some people say. Do you have a half an hour to do something like this in the field? I know a lot of you work on residential, smaller stuff, and it's tighter stuff, but when you work on more into commercial stuff, you do have a little bit of time, you know. And you can do this. All of you can. I know 100%. You're sitting here today, I know you can do it. Okay, so we pulled it off. We understand that. The next step is to take off the pump. These are the two things that all you need to do is after you pump it down is pull off the head, check the valve plate, and pull the pump off because you want to do something. You want to do the wrist pin check, and you want to do the main bearing check of a semi-hermetic compressor. Okay, so if you want to just take off these bolts here and see if we can knock that pump off. Not those ones, just these ones. Yep. Yeah, that's a big thing. You got to educate your customer as well, because this could save the customer $10,000 for a $400 service replacement or a fix, a repair. Yeah, just that. This one.
Or this one?
No, just this one. And I don't know if we'll be able to get it off. And always, like, it's easy on Copeland's. You can scan the model number and get all the information of that compressor. Okay? You can do it with, the Bitzer does have a scan software, so you can scan the Bitzers now. Tecumseh, I can't remember. I don't know if they have a scan one yet, but you can get all their information. Oh, yeah, take that off. Yeah, pull that off then. So you want to pull off the head safely, pull off the valve plate safely, and you want to take off the pump. And as a technician, if you do this, you're going to be able to tell the story of that compressor. Because what check when I pull off this pump, what are the two things we're going to be looking for? Does anybody know? What's that? Yeah, on the pump. You got all the bolts out?
Yeah.
Okay, let's see. Yeah, oh man. Oh, well, let's see if we can pop it off.
Cast iron never breaks.
We may not get it off, but. Okay, well, we're not going to get it off. Not going to spin it. I've taken a lot of compressors apart, but, and not in a very nice way. But you want to take this off here, okay? When you take that off, it's the crankshaft's right there. That pump is connected to the crankshaft, and the crankshaft has holes drilled through it. So as it's spinning, oil is going up and feeding all the journals, all the bearings. And so if you have flood back and you have that liquid refrigerant coming back because it's not boiling off in the evaporator, it goes inside. You got it? Awesome. Okay, so Yeah, spin it around, see if you can pump. So look, mechanically, I know some of you can't see it, but it's pumping okay. So now see if they all go up dead center. So that one goes top. Let's check this one that'll blow. Keep going. Oh, see, this one doesn't. So now, if you didn't do this check and you said, okay, I'm just going to replace the valve plate, well, the compressor is going to be in big trouble because there's a wrist pin wear on this one. So now it's like, instead of spending $1,000, that customer to do a valve replacement, or $2,000, they're going to spend $2,000 plus you coming back and replacing the compressor again. Because the wrist pin here is done. So did you hear that?
Yeah. Blump, blump.
Hear
It
that?
says a little space there. It's moving.
You hear that? I know it's hard to hear, but did you guys hear it? Oh, you did? Okay. That's wrist pin wear, and that is due from, what was it due from? What's the story? Okay, flood at start. Well, it was actually, it's even before that. It's the migration that caused the flood at start, that caused the slug, that busted the discharge valve, which led to discharge pressure pushing onto the pin, which led to oil not being able to get up into the wrist pin, which caused wrist pin wear. So there's a whole story there. And it doesn't matter, this is just one story on this one compressor, but every system has a story. And the other check, so that's a wrist pin check. The other one is, you can move this back and forth, but it's up and down play. So try to do up and down to see if you got any up and down play. What do you think? Back and forth's okay, but up and down. Nothing. But if you get that up and down play, I know 100% that was flood back. 100% I know that was flood back because the main bearing that's right in here has been wore. These are the things that you need to think of, John.
Question. Okay, we have a bad valve plate on the discharge side. Flood back as far as how it affects the suction read.
So flood back will not affect the suction rate. Flood back is going to affect the oil. So it dilutes the oil. So as the oil is picked up, because there's holes drilled in this compressor, they're different, it picks up the oil, it goes through this pump here, and the pump feeds it through all the journals, all the holes in the crankshaft, which goes to this last main bearing right here. So here's where it's separated, here's where it goes, which held onto the stator. Okay, so what happens to that main bearing if it starts to wear? What happens to the crankshaft? Does it stay nice and level? It starts to sag, and then what happens? Starts to cause something called rotor drag. And so you hear, woof, 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 and then you get electrical failure. So if you don't look inside and do this check, you come up, oh, I'm grounded, I'm shorted, I'm turn to turn, whatever it is. You say, okay, let's just replace the compressor. But if you didn't check that, oh, I have real bad flood back happening, that's why the compressor failed, because that stator dropped, because the main bearing wore and caused that stator to fail. So here's a whole story. Thanks, Max. I got to understand that story. So flood back.
So what causes suction read valve to fail?
Okay, great question. What causes suction reed valve to have issues or fail?
That's the majority of what I found on Motec.
Okay. Okay, what does anyone think? So reed valves would be these ones here, that this one here has failed. So what would cause that? Anybody? What do you think? So a slug would cause them to fail? Is one, right? So a flooded start that causes a slug.
This is all
What
to
else?
do with liquid.
Liquid. So overheating could cause it. Metal fatigue, exactly, could cause it. But this is why you need to look at it. Really low compression ratio could cause it. Because the reed, they start flapping like this. So there's many different things, and this is why you need to understand the story of that compressor. And will you know the story when you go and the compressor's failed? No. You will have to put a compressor in. But if you don't figure out what caused that compressor to fail, how do you know how long that one's going to last? If that makes sense.
That has to be liquid because it's round, it's like it was trying to compress something.
Okay, thank you very much.
Thanks.
Thank you very much.
You want us to put it back together?
No, just leave it like that for now. We'll pick it up afterwards. Okay, we only got a few minutes left, and I love talking, so I could talk here for another 6 hours, but I know it's hard to see. What would have caused this? This is like this. This is similar right here. So that would be, that's on a K body, so there's a bearing inside here. What would cause this bearing that gets the oil, the first place that gets oil? What would cause that? It's not getting none. But this is the first place where it gets oil. Wash out. What else? I haven't heard it yet. Trapped oil. What else? Bad oil. Refrigerant migration. Flooded starts. This is the first place that gets oil. Unless I look at this compressor and it's all burnt and everything's black and it ran out of oil and this seized off. But if I go to try to take an oil pump off and it's stuck there and I can't pull this off, that means refrigerant must have got in there and washed out that oil. Because oil should be everywhere, okay? So if it's stuck in there, most likely that's a flooded start to cause that. What about this one here? This is the bottom of a scroll. The bottom underneath of the scroll. If you pull it off and it looks like that or it's seized, cut open a scroll, and that's the thrust surface. You have liquid that comes up the crankshaft and feeds everything with oil. That oil doesn't make it up there. When you open a compressor and it looks like that, and that's the bottom, that's the oscillating scroll, and that bearing's war, that is 100% flood back. Because that liquid comes down to suction, gets in the oil, it goes up the crankshaft, and starts to wear, washing out the oil. This one here, we just talked about this. This is a rotor. What caused this one? I know it's super hard to see. That's the stator. Here's the rotor. We just talked about it. The bearing fail. Why did the bearing fail? Didn't have lubrication. What causes the thing to not have lubrication? Flood back. So this is what you need to understand the difference, because I could say liquid. Oh, it's liquid. Yes, 100%. But what type of liquid? Why? How? Where's it coming from? Is it flooded starts? Is it flood back if it's slugging? You need to understand this to find that story out. This one here should be obvious. Overheating. But what caused that overheating? We talked about it. It could be compression ratio. It could be a restriction. It could be the condenser fan is the wrong condenser fan. Wrong condenser fan blade. Yeah.
That's the difference. That one's like the dust of stuff inside that became like.
That's carbon, yeah. So this is oil broken down and it's carbon. And there may be metal and stuff as well in there. But just on the condenser, it could be the fan blades are put on backwards. It could be the wrong fan motor. It could be the wrong stage fan motor. It could be a dirty condenser. These are all different things just on the condenser alone that could cause something that looked like that. Overcharge. Well, overcharge, yeah, because you have, yeah, you're right. What's this one here? What would cause this? Slug. So you got, and it takes time to learn all this. I didn't learn this overnight. I've been spending years on it. But just by looking at pictures, what do you think? This is a good one. This one did come from Steve Wagner. How long do you think this compressor was in the field? And do you think it was a failed compressor? Let's start. How long does it look like it would have been in the field, but just by the picture? What? A while. Years and years. Okay, first of all, it was only in 2 weeks. Brand new compressor. Why does it look like this? Why do you think it looks like this? Rust. Why do you think? What's that? No. 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 Loose connection? No. I thought the same thing when Steve sent it to me. He said they didn't change the lugs. They didn't change the lugs. Okay? Okay, and then they put it on, and then, I don't know, it might be hard to see right here. What does it look like here? Can you see that? Can you see the carbon tracking? Do you know what Steve told me? He said he pulled that off, and the compressor was 100% fine. So these are the things you need to dive in a little bit deeper. And I'll be honest with you, before I worked for Copen, when I did work for them, I didn't know this stuff. And this is why I'm sharing this knowledge with you, so you can share it with somebody else. Okay, a couple mobile apps that you need to have if you don't have them. How many of you have Application Engineering Bulletins by Emerson? Yes, Copen Mobile. Bitzer, B-Spot. Awesome. HVAC School. There you go. You need these apps. Yeah. You need to have, and there's many more. I just put a few up there that's going to help you with your troubleshooting skills, your learning skills, and growing. Okay, educational resources. You should know a lot of these ones. HVAC School, Chris Stevens from HVACR School, the Tool Shed guys. You want to learn some stuff. These are the people you should be following. R744, I recommend that because I do a lot of refrigeration training. I love CO2 natural refrigerant, so it's a good place to learn about something that you don't know much about maybe. And then HVAC Know-It-All, another influencer in Canada that shares a lot of knowledge with the industry. So you should be looking these guys up. Find the information they're put out there. So I do have an in-depth compressor masterclass coming up actually in a week and a half. So if anybody's interested in learning more, diving, I just touched the surface here. Just touched the surface here. So if you're interested in more deeper learning, you can head to my website, check it out. It starts next Saturday the 26th. And I got a knowledge test. So for this, if you guys want to do this, I built a little quiz for the symposium, 10-question quiz. You can write down the link right here and do the quiz. Or you can go to my website, go to courses and do quizzes, www.refrigerationmentor.com. Go to courses and quiz and do a 10-question quiz on what we talked about today, just to test your knowledge. If you do the quiz, you submit it, you'll get 10% off the course that starts in a week and a half. I'll give you 10% off. If you just submit the course, it doesn't matter if you get 0 on it or 10 on it. But test your knowledge. See if you learn some of this stuff. Because you need to test your competency. It's super important. So you can find me in lots of different places. Facebook, YouTube, LinkedIn, my website, refrigerationmentor.com. I got all the podcasts I've done with Brian and other influencers in the industry, trying to get out there, share more knowledge to help the industry out.